Okay, let's look at this geometry problem. I'm going to do it a little bit different because I'm not going to put all the solutions. You've got the memo in front of you. You can take a look at it yourself, and I'll just explain it, and I'll explain the reasons in words. So maybe that'll work okay. Let's just try it for this question. It says prove that K1 is equal to half. K1 is equal to half of the angle KOM. Well, how are we going to do that? How are we going to prove that? Well, let's see here. This is what we would do. We could say that's the angle between a tangent and a chord. And what does it equal? It equals the angle that subtends that same chord. And the angle in the alternate segment, it says, yeah, up there. So that angle L must be x because of the tan chord theorem. So that's what you have to do to get started. Well, then you can say that the angle KOM is twice as big. It's 2x's. And why is it 2x across here? Because the angle at the center is twice the angle at the circumference. The angle at the center is twice the angle at the circumference. And why do we know, why do I know that it's half of this? Because they told us up here right in the beginning that OT bisects it, cuts it into two equal pieces. So this x is exactly 1/2 of what this is here. Okay. And, well, we kind of knew that. It's the angle at the circumference is half as big as the angle at the center, and it breaks up into x and x like that. Let's take a look at the next question. Prove that KOMT is a cyclic quadrilateral. Well, KOMT, now we could put a circle around these 4 points. And why could we do that? Because look, O2 and K1 are equal, and they open up to the same segment, TM. So we could say that KOMT is a cyclic quadrilateral, and the reason is the converse of angles in the same segment. You see, if angles in the same segment, if you have a cyclic quad, angles in the same segment are equal. But if you have equal angles that open up to the same line, then you can say by the converse of angles in the same segment that it must be a cyclic quad. So this is a cyclic quad because the angles in the same converse of the angles in the same segment. Maybe we can do one more. Let's do one more. This one says, prove that triangle, prove that triangle KM 11.3. It got mixed up in the different questions here. So let's prove this one first. Prove that triangle RKM, so there it is, RKM. We're going to prove that triangle RKM, there's one green triangle there, I should have used a different color, is similar to triangle ROT. Well, I said ROT and RKM. But we started with R. So we're going to prove that these two triangles are congruent. We can just say that R is common. R is common. Okay, so that's one of them done. And we've already done this before. O2 is x and K1 is x. So we've got another angle, K1 and O2, that are the same. Well, we've just proved, if we show that two angles match up, the common angle and these two here, angles x, then we can say that triangle RKM is similar. And the reason is we can write down angle, angle, angle. That's the reason that these triangles must be similar, because we matched up two pairs of angles. Okay, well that's it. There you go.